Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into the concept of semantic chunking. This is the most interesting type of chunking strategy. Without further delay, let's dive into semantic chunking strategy. First, let's have a look at the official definition of semantic chunking. And here it is. Semantic chunking is a method of splitting the text based on the meaning and context. It ensures that each chunk is semantically coherent unit. Here, we do not use any strategy which will divide the chunks into fixed sizes or with fixed overlaps. Here, the chunks are created based on meaning. Let's say we have a text file which contains 5 paragraphs. The first 3 paragraphs are talking about one particular topic, and the last 2 paragraphs are talking about another particular topic. So, with semantic chunking, there will be two chunks created out of the text file. First 3 paragraphs will be a part of the first chunk, and the last 2 paragraphs will be a part of the next chunk. Here, there would be no fixed size. Even there are no separators involved in this particular type of chunking. Here, every single chunk will be ideally independent of the another chunks because all the information that is relevant to a particular topic will be present in a single chunk. So I hope by the definition, you might have got a basic idea of what exactly semantic chunking is. Now, this particular method uses natural language processing techniques to understand the text and split it at logical boundaries such as sentences, phrases, or even topics. Now, as I already said, that here we are not going to set a particular boundary for creating chunks, for example, fixed size boundaries. So that is why here we use some techniques from NLP to create semantic chunks. So that was just a simple overview of semantic chunking. Now let's move on to the working of semantic chunking strategy, how it works. So let's have a look at the working. First, we need to apply the sentence tokenization to split the text into sentences. Now, obviously, in a particular text file, there might be a lot of information. Initially, we'll have to create some custom chunks from which we can then create the actual semantic chunks. So for creating the custom chunks, we can use this sentence tokenization. We can split the entire text file based on sentences. That means one single chunk will contain a single sentence. Now, it's not mandatory to use sentence tokenization. We can also split the entire text into paragraphs also. Even we can split it into couple of sentences. We can set the boundaries. Now note one thing, this is the initial stage of chunking. Here we just create custom chunks so that we can apply the NLP techniques on these custom chunks so that we can get the semantic chunks. Now once the sentences or I would say the initial chunks are created, then we can simply analyze the meaning and context of each and every sentence. Here we are simply talking about one single sentence, but as I said, that we can also apply this technique to split it into paragraphs also. Now, here we analyze the meaning and context of each sentence. Now, this can be done with the help of embeddings. Now, there are a lot of open source as well as paid embedding models available. You can define your own custom model also. So, in short, we have to create embeddings of every single sentence and then we have to analyze the meaning and context of each sentence so that we can group them afterwards. Now, once we analyze the meaning and context of each sentence, we can simply group the sentences or phrases that belong together based on their semantics. So let's say we have 3 sentences. We create embeddings of all the 3 sentences individually. Then what we'll do, we'll simply analyze the meaning and context. This means that we are going to find out the similarity between these sentences. We'll group those sentences which has the highest similarity score. Let's say the sentence 1 and sentence 2 are having the highest similarity score, and sentence 2 and sentence 3 are having the lowest similarity score. Then we can simply group sentence 1 and 2 and create one chunk of it. And since sentence 3 is alone, we can create a single chunk of sentence 3. So this is how we group sentences or phrases that belong together based on their semantics. The speciality of semantic chunking is that it ensures that each and every chunk is coherent unit of meaning. So in short, we can say that each chunk will be a complete chunk. So I hope the working of semantic chunking is clear to you all. Now let's have a look at the implementation of semantic chunking strategy in Python. Do you want to check out this attractive funny memes? Then what are you waiting for? These are just a glimpse of the memes that I've created on my Instagram page. You can find the link to my Instagram handle in the description box. Please visit the link and do watch all these interesting funny memes. These are not just memes. These memes and reels contains technical information. Here I try to relate memes with the technological concepts. So please do appreciate that by watching all those. And if you love it, please hit the follow button. Now let's see semantic chunking implementation. Now over here, let's consider a simple paragraph. Now this is a sample paragraph that I have taken. This contains some text related to large language models. So here we are going to create chunks out of it, and those chunks will be created with the help of semantic chunking strategy. Now according to the algorithm, the very first step is to do sentence tokenization. Now, I already said you that as per the use case, if your data size is actually large, then you can also do paragraph tokenization, or you can create custom chunks of some number of sentences initially. But here our data is very much small, so I'll be doing sentence tokenization. So for that, I'll be splitting this entire text based on sentence initially. Now for doing that, I can use split method. Otherwise, I can use regular expressions. Here in this particular video, I'll be using regular expressions. So for doing that, I'll be defining a function which is named as split para to sentences. And this particular function will take the paragraph. What this is going to do, it is simply going to split the entire paragraph based on sentences. So sentences equals re.split, and here I'm going to define the expression. Now for regular expression we have the re library in Python, so we'll simply import that, and inside this split function we are going to define the pattern. So here we are going to split the sentences based on full stop. So let's write the expression for that. So this is the expression, and the split method also takes second parameter, which is nothing but the paragraph that we want to split. Now this is going to return list, which will contain sentences present inside this paragraph, and it will store it in the variable sentences. Now I'll simply return the variable sentences. Now let's execute this and let's check whether we are actually getting sentences out of this paragraph. So let's pass the para variable in which we have stored our paragraph. Now let's execute this and let's see the output. So over here you can see that we are getting list of sentences. These sentences are splitted based on full stop. Now as per the algorithm, we are done with the very first step. Now let's move on to the next step. And the next step is to analyze the context of each and every sentence, which means here we are going to convert every single sentence into its vector embeddings with the help of an embedding model. Now specifically in this particular video, we'll be using Hugging Face embeddings. So we have a method called as Hugging Face embeddings from LangChain. So we'll import that from LangChain dot embeddings. We'll import Hugging Face embeddings. So this is the method. We'll define our embeddings in the variable named embeddings. Now since we are using Hugging Face embeddings method, this particular method takes in a model name that we have to give. Now there might be tons of models available for performing embedding operation on Hugging Face. We have to choose one wisely for our use case. For now, I have chosen BAAI DG Large You can choose any embedding model from Hugging Face website. You just have to put the name of that particular model here. Now let's execute this particular cell. Now over here you can see we have got a dependency error. We have to install sentence transformer Python package. So for that, we'll simply execute this particular command, that is pip install sentence hyphen transformers. This will simply install the sentence transformer package for us. Now you can see that the sentence transformer package has got successfully installed. Now let's execute the same code again in a new cell and let's see whether it works or not. So let's execute this. Now you can see our model is getting loaded in embeddings variable. This will take some time, and here you can see our model has got loaded. So basically we have our embedding model in the variable embeddings. We can use the embed query function to create vector embeddings of a particular query. Now in this function, we just have to pass on the query that we want to embed. So let's say I write this, I love Gen AI, and let's execute this. So here you can see it has created a vector of this particular query. This is how we can create embeddings with the help of any model. Now, if we carefully look that this is in the form of a list, let's try to check the length of this particular vector. Now, the length here represents that for each query, the model that we have used, that is BAAI, BG large, it creates 1024 dimensions of every single query. Now that we have gained ample idea about the embeddings, now let's try to create our custom function, which will create semantic chunks for that particular paragraph that we have taken as an input. So let's define the function. So let's name the function as create semantic chunks. So this particular function will take the sentence list. Now since we have our embedding model ready, we can simply create sentence embeddings for each and every sentences. So I'll use list comprehension for sentence in sentences. What I'll do is I'll simply use this particular embeddings.embed query function and I'll simply create embeddings of every single sentence one at a time. And the embeddings of all the sentences will be stored in a list. Now, since we are going to perform some operations on this particular vector embeddings, just to make things easy, we are going to convert this particular vectors in a 2D NumPy array. 2D NumPy array are always the best to perform operations. So for that, we are going to first convert this particular embeddings into numpy.array. And for that, we are going to import the numpy module and we are going to give it an alias as np. So this np.array will convert this particular embedding vectors into an array. And once it is done, we are going to reshape it into 2 dimensions. We can do this with the help of the dot reshape function and we can simply pass this parameters 1 comma minus 1. This will convert it into 2D numpy array. And obviously we are now going to store all the vector embeddings in a list. Now let's define a list which will store the semantic chunks. Now how our approach will be, we'll simply iterate over all the sentence embeddings. We'll find out the similarity of the first sentence with the second sentence. If the similarity score is greater than 0.5, then we'll combine them. Then we'll club sentence 1 and sentence 2 into one single chunk. Then we'll move on to sentence 2 and sentence 3. If the similarity score between sentence 2 and sentence 3 is greater than 0.5, then obviously we'll club it into chunk 1, which contains sentence 1 and sentence 2 already. And if the similarity score between the consecutive two sentences is lesser than zero point 0.5, then in that case, we are going to separate them into different chunks. So for that, I'm going to define a for loop. For I in range will iterate over the number of sentences. Here, we can get the number of sentences with the help of the length function. And inside this, we'll simply pass on the sentences variable, which contains a list of all the sentences. Now, initially, obviously, we'll have to create one chunk which will contain the first sentence. So for that, what I'll do is if the counter, that is I equals 0, I'll simply write semantic chunks dot append sentences of I. That means the very first sentence in this particular case, since I is 0. So once the first sentence is encountered, it will be a part of the very first chunk in the list. Now, if the counter is not 0, that means if it is not the very first sentence that we are iterating on, then in that case, it should go in the else condition. And when it goes in the else condition, we will have to compute the similarity score between the current statement with the previous statement. Now we'll simply define similarity variable which will contain the similarities between the current sentence and the previous sentence. Now for computing the similarity score, we are going to import the cosine similarity module from sklearn dot metrics dot pairwise. From this, we are going to import the cosine similarity. Now, what this cosine similarity does, it takes two parameters, that is the first sentence and the second sentence, and then it will compute the similarity score between these two. Now, here in our case, we have our sentence embeddings stored in the variable sen embeddings. This contains the embeddings of all the sentences in a list format. So we'll use the variable, and from this variable, we want two consecutive sentences. Now here, we'll simply write I minus 1 because I minus 1 represents the previous statement, and we will write the second parameter as sen embeddings of I. That means the current statement. So this becomes two consecutive statements. This cosine similarity will compute the similarity score between these two consecutive statements, and it will store it in the variable similarity. Once the similarity scores are taken, we'll simply now create chunks by defining some conditions. If the similarity score is greater than zero point 0.5, so if it is greater than zero point 0.5, that means the two sentences are similar. Now, if they are similar, that means we'll write semantic chunks of -1. Now, why I'm writing -1? Because whenever the similarity score is higher, we are going to append the current sentence in the last chunk that we have already created. That is why I have written -1 over here. Dot append the current sentence, which is stored in the variable sentences, and the index is I, that is the current index. Now note one thing, the similarity score is present at the first index of the first index in the similarity variable. So you can just imagine this is a list wherein the similarity score is present in the list which is present at the first index. And from that list again, at the very first index, we have our similarity score. So that is why I have defined similarity of 0 of 0. Now, if the similarity score is greater than zero point 0.5, we have handled that particular scenario. But if it is not, then in that particular case, it will go in the else statement. And in the else statement, we can simply write that semantic underscore chunks dot append sentences of I. Now here we are going to append the sentence as a new chunk. That is why we are going to enclose it in a list. So I hope you are understanding that our semantic chunks will be a list of lists. Each list in this particular list will be one single chunk. It will contain some sentences. As per this particular algorithm, if the similarity score between two consecutive sentences is greater than zero point 0.5, then in that case, whichever is the current chunk that is present in that particular semantic chunks, in that particular list only we are going to append this particular current sentence. But if the two consecutive sentences are not similar, then in that case we are going to simply create a new chunk in this particular semantic chunks, and the very first statement will be the current sentence in that particular new chunk. So I hope this particular simple logic is clear to you all. And finally, we are going to return the semantic chunks. So we are now done with this particular function definition. Now it's time to test this particular function. So let's execute this first. And now since we already have created sentences, let me show you that. Here it is. But we haven't stored it in a variable yet. So let's simply copy this and again paste it in the new cell, and let's store it in a variable named sentences. Basically, this will split it into sentences. So the paragraph is now split it into sentences, and in the sentences variable, we have all the sentences. You can see. Now what we'll do is we'll simply pass this particular variable in this particular function named create semantic chunks. Let's pass the sentences inside it, and let's check what happens. Okay, so we have got an error. It says that string object has no attribute append, and the error has got arise in this particular situation where it comes under this if statement. Now here, if we carefully look, our semantic chunks is a list, and the semantic chunks list contains again list. So at the time of creating the very first chunk, where when I was actually 0, what we had done, semantic chunks dot append sentences of I. So basically here in this particular semantic chunks, instead of creating a new list and then appending the first statement in that particular new list, we have directly appended the first sentence in the semantic chunks list. So we should not do like that. We'll have to enclose this particular sentences of I in a list, because this is the first sentence in the first chunk. And I think this will solve the error. Let's try to execute this particular function again. Let's create sentences again, and let's execute this particular function call again. Okay, so now we have got this particular chunks. Let's try to analyze this. Let's store it in a variable named chunks, and then let's see the length of chunks. How many chunks we have got? Okay, so out of the paragraph, we have got total 3 semantic chunks. Let's see the first chunk, what exactly it is. So this is the very first chunk. It contains almost, it contains 3 sentences. Now why it contains 3 sentences? Because it found out that these 3 sentences are similar, and that is why these 3 sentences are a part of the first chunk. Now let's analyze the second chunk. Now here we have got only one single sentence in the second chunk, because there might be some words or there might be some context that might not match with the previous sentence. And that is why the score was less, and because of which this particular sentence was not a part of the first chunk. Now let's analyze the third chunk. So here you can see we have got our third chunk. This contains multiple sentences, and you can see in this particular chunk that almost every single sentence is similar. Even by reading, you can understand these sentences are directly attached with each other. Here, you can see every single chunk is not of the same size, even there is no overlap present, but still these chunks are acting as standalone chunks, and these are more powerful than the chunks that we have created from the previous methods. Now, this was a simple algorithm that we have used where we have checked the similarity between consecutive sentences. But we can apply some other logic. We can have couple of sentences together and then check the similarities between those couple of sentences. We can have similarity check between the paragraphs and so on. We can have multiple such ideas based on the use case that we are working on. So I hope the entire implementation of how we can create semantic chunks out of the text that is provided is clear to you all. I have tried my level best to explain this simple function. If you are still not clear, then I would recommend you to watch this particular section again. Your doubts will be cleared. So that was about the implementation of semantic chunking strategy. Now let's see when to use semantic chunking strategy. While processing the text, where preserving the semantic integrity is crucial. I already have shown you an example where semantic chunking will suit the best whenever we have a paragraph or we have multiple text files in which fixed size chunks cannot be made, or maybe the chunks that can be made with the normal method won't work while the retrieval process. In that case, we can go for semantic chunking. When dealing with documents that have complex structures and topics. So I already said that semantic chunking is very much powerful. It can almost deal with all the documents that have complex and difficult structures as well as the content present inside it. For natural language processing tasks that require meaningful and contextually rich text segments. If you correctly implement the semantic chunking strategy as per your use case, then it will serve as the most useful chunking strategy for your use case. It will help you to retrieve the most relevant chunk to any particular given query, and which will obviously increase the results of the RAG pipeline. So I hope when to use the semantic chunking strategy is very much clear to you all. Now let's have a look at why to use semantic chunking strategy. First, for semantic integrity, it ensures that each chunk is meaningful and contextually appropriate. Only this type of chunking strategy will be useful to create meaningful and contextually appropriate chunks, because here every chunks are created with the help of natural language processing technique, and which is very powerful. Secondly, we use the semantic chunking strategy for improved NLP performance. It enhances the performance of downstream NLP tasks by providing coherent input. Semantic chunking strategy is also going to be used to preserve the context. It maintains the logical flow and context of the text. So I hope the usage of semantic chunking is very much clear to you all. I have tried almost everything to explain you about semantic chunking strategy. I hope every single concept related to it with its implementation is very much clear to you all. If you guys have any single doubt, then you can straight away put it in the comment section. I'll be very much happy to solve it. For more such videos, do like, share, and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. Thanks for watching. Have a good day ahead.